Okay, we're still in lesson 8-8, the reciprocal function family, and we want to first look at the ways that we can transform our reciprocal function. So this is a really good box to keep in mind. It's on page 509, and we know that the parent function is y equals x, where x cannot equal 0. And we know that we can stretch, we talked about this in a previous video, we can stretch our function if we have a value of a and a is greater than 1. It has to be positive. It's greater than 1. So that's why they have the absolute value there. It can shrink. That means get fatter or whatever you want to think, however you want to think of it. Get closer. And that's a number between 0 and 1. So those are those fraction numbers, those numbers that are less than 1 but not negative. And then it reflects if it is negative. And all the reflections also can apply to the shrink and the stretch. For translation horizontally and vertically, my horizontal translation is given to me by h, and my vertical translation is given to me by k. So that means it goes either vertical is up and down, and horizontal is left and right. And it also tells me the asymptotes. The vertical asymptote is going to be my h, so it is x equals to h, and my horizontal asymptote would be y equal to k. Okay, and we have to also remember that x cannot equal h because this cannot be 0 here. So, and then combined, everything combined, my a can still make it stretch, shrink, reflect, and I can still translate. So let's look at the example problem 3. So graph and translation. It says, what is the graph of y equals 1 over x plus 1 minus 2? Identify the domain and range. So they did a whole bunch of stuff here, which was awesome. But I'm going to use my free graphing calculator at www.desmos.com. And I'm going to put it in. So I have y equals 1 divided by x plus 1. And then I have a minus 2. Okay? And just so that I know what I'm working with, let's put my parent function, which is 1 over x. So the blue is my parent function. And I'm going to come out just a little bit so that I can see it a little bit better. So my parent function is the blue, and my transform function is the y. I'm going to go ahead and also put my asymptotes here. So here I have a plus 1. And remember, the formula lets us know that we should have minus h. So that means that I'm going to use the opposite sign of this because I have a plus here. So a plus and a negative. So for example, if I can really think of this as x plus 1 is the same thing as x minus a negative 1. So that means I'm really dealing with negative 1. So I'm going to put that in my graphing calculator so I know what it is. So I know where it is. X equals negative 1. And I'm going to change the graph of it. Change the way it looks. Instead of a line, oops. I'm going to edit with dots. There. Okay, and we see here for my red, kind of messes up my blue, but as you see for the red, it gets closer and closer to it, but it doesn't touch it. Okay, and so now for my y, we know my y is this minus 2. And again, I am going to, oops, it's supposed to be a negative 2. And I'm going to, oops, edit this, change it to dotted instead so we can see. And as you can see, again, for this, I am getting closer and closer to it, looking at the red one. Getting closer and closer, but not touching it. So it's getting closer and closer to the green and the y. And so this also lets me know my domain and range. So x can be, for my domain, all real numbers. This is values of x, so all real numbers. Except x cannot equal negative 1. All right, and the range is the same idea as all real numbers. except y cannot equal, I think it was -2. We can go back and check. Yes, -2. Alright, so now let's take a look at my got it. So it says, what is the graph of 1 over x minus 4 plus 6? Identify the domain and the range. So I'm going to use my free graphing calculator again. Let me get rid of these. We'll keep let's keep the original function. Oops, sorry about that. And let's put 1 over x minus 4. And then plus 6. And we can see that transformation again from my blue to my red. I have moved over to the +4 direction, and then I've gone up 6. Okay, so I've moved over to the right 4 and up 6. The exact same function. I've just moved over 4, up 6. And we can put our asymptotes again. So that's x, and this time we can leave it as 4. And as you can see, it gets closer but doesn't touch. And then the same for y. Y is equal to 6. Again, it gets closer to it but doesn't touch. So it's the same ideas as before. My domain, I'm just going to use my symbol of all real numbers except x is not equal to 4. And range is all real numbers except y is not equal to 6. Okay, so those are the values that it cannot be, or those are my domain and my range. I hope this helps.